Let's understand how to draw Turing machine or how to design Turing machine for the given language. Here input string is given. For this string we need to draw the Turing machine. Before we draw Turing machine, let's understand how Turing machine works. Suppose for the given language L is equal to a power n, b power n, c power n, where n is greater than or equal to 0, there are many strings which this language will accept. Suppose A, B, C, epsilon, because there is n is equal to 0. So null string will also be accepted by this language. Double A, double B, double C. This string is given in this example. For this string, we need to trace out the Turing machine. Now the triple A, triple B, triple C, like this many strings will be accepted by this language. Now let's understand that how Turing machine works. For this string AABBCC, we need to mark 1A as X. Like first step, now we need to find matching B from this given string. Here matching B is this. Then mark that B as Y. Now find matching C. Mark as Z. Now return to the left. Return to the left until we get the first X or first A. Now mark second A as X. Now find the matching B, that means this, and mark B as Y. Then find the matching C and mark C as Z. Now, as all the letters are marked, we can say that the given string is accepted by the Turing machine. So here how Turing machine works. Now let's see how we will draw Turing machine. Let's take string AABBCC. Before the string and after the string, we can have n numbers of blank space. Like this. Initially, the read-write head is at the first A. We need to replace first A by capital X, or you can take any letter apart from that A. Now, after replacing the first A with the X, we need to move towards the right. We need to move towards the right until we get the B. That means in between first A and first B, whatever number of A will come, we need to keep those A's as it is. So here we need to keep this A as it is. Now, as B came, we need to convert that B into capital I. Now again we need to repeat that until we get the matching C, we need to keep this B as it is and convert this C into capital Z and move towards the left side. We need to move towards the left side until we get the capital X. What does it mean? That means in between whatever letters come, we need to keep those letters as it is. That means now what will be the string? X, A, capital B, small b, Z, C, B, 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 B. When we reached at capital X, the string would be like this. Now capital X occurred, we need to keep that capital X as it is and move towards the right hand side. Again the small a occurred, so we need to convert that small a into capital X and move towards the right. Again, until the matching B occurred, we need to keep in between letters as it is. So here capital Y occurred, so we need to keep capital Y as it is and convert that B into capital Y and move towards the right hand side. Again, matching C occurred. Till then, we need to keep capital Z as it is and convert that C into capital Z and move towards the left hand side. And we need to move towards left hand side until we get X. Now, when we get X, our read write head will be at here. Now, if we reached at here, we need to move towards right hand side. And until we get the blank space, we need to keep all the letters as it is. So capital X, Y, Y, Z, Z, and now read write head is at blank space. Now when we get blank space, that means our string is accepted by the Turing machine. Now let's draw the Turing machine based on our thinking. Let's start with Q0 state. At Q0 state, for the given string AA, read write head is at here, small a. Now, for first a, we need to convert that a into X. So, how we can write in Turing machine? If we give Q0 state a, we need to convert that a into X and we need to move towards the right hand side. So, here we need to write R and the state will be changed as Q1. Here, if we give Q0 state a string, it will be converted into X and it will move towards the right hand side. So like this, a is converted into X and we need to move towards the right hand side. So now read write head will be at small a, second small a. Now we have seen that until we get the corresponding B, we need to keep in between any letter or string as it is. So we need to keep this a as it is. So how we can write in the Turing machine? If we give Q1 state a, we need to keep a as it is and move towards the right. So now read write here is at here. Now as B occurred, we need to convert this B into capital Y. So we will convert B into capital Y and change the state again. So if we give Q1 B string, we need to convert that into capital Y and move towards right. So now read write head will be at small b, second small b. Now again the same process until we get this corresponding C, we need to keep this B as it is. So here in this state, we will write small b and R. That means if we give Q2 state B string, then we will keep B as it is and move towards the right side. So if we move towards the right side, the read write head will be at small c. So now convert C into Z and move towards the left side. So if we give Q2 state C, convert C into Z and move towards left hand side. We need to move towards left hand side until we get the capital X. So in between whatever letters come, we need to keep those letters as it is. So how we can write? Now read write head is at small b. So we will move read write head at small b. As we have seen that we need to keep b as it is because we have not reached at capital X yet. So at this state we need to write b, b and move towards left. Now capital Y occurred. So we need to write capital Y as it is and move towards left. Now small a occurred. So small a and left. Now read write head is at capital X. When capital X occurs, we need to change the state, and that state will go at Q0. Capital X occurred, then keep capital X as it is and move towards right hand side. So now we need to move this read write head towards right hand side. Now read write head will be at this small a. Now this small a we have written like this. If small a occurred, convert it into capital X and move towards the right hand side. So let's convert this a into capital X. Now read write head is at capital Y. Now we are at Q1 state. We are at Q1 state when the read write head is at capital Y. Now if we give Q1 state capital Y, we need to keep that capital Y as it is and move towards the small b or move towards the right hand side. So we need to write here that if we give Q1 state capital Y, keep capital Y as it is and move towards right hand side. So now read write head will be at this. Now B occurred, and from this diagram we can see that if we give Q1 state small b, we need to convert that b into capital Y and move towards the right hand side. So we will convert this small b into capital Y and move towards the right hand side. So we are right now at Q2 state. Now at Q2 state, the read write head is at capital Z. So now we need to keep that capital Z as it is and move towards the right. Then read write head will be at small c. Now if we give Q2 state small c, we need to convert that small c into capital Z and move towards the left hand side. So we will convert this small c into capital Z and move this read write head at left hand side. Now after converting that small c into capital Z, we are at the Q3 state. Now we need to move towards the left hand side until we get the capital X. So till then these all letters would be same as it is, no change. So if we give Q3 state again capital Z, we need to keep that capital Z as it is and move towards the left hand side. Now after moving left hand side, the read write head will be at capital Y. Now we are here only in Q3 state. If we give Q3 state capital Y, we need to stay on capital Y itself. So here we have already written capital Y and L. So we need to move towards the left hand side. Now again capital Y. So it will follow this again. Now read write head is at capital X. Now as Q3 identify that there is capital as Q3 identifies that there is capital X, now this Q3 state will change to the Q0 state. That means Q3 state will go to the Q0 state. That means capital X remains as capital X and move towards the right hand side. That means now this read write head move towards the this. So now read write head will be at capital Y again. Now when again capital Y occurred, we need to change this state Q0 to new state, that is Q4. Here we need to write that keep capital Y as it is and move towards right hand side. So now read write head will be at here. Now we need to stay in the same state. So we will write here Q4 state, capital Y occurred, keep capital Y as it is and move towards the right hand side. Now until we get the blank space, that means capital B, we need to move towards the right hand side. That's why we are keeping capital Y and capital X as it is and moving towards the right hand side. Now read write head will be at capital Z and we need to stay in that state only. So capital Z and R. Again we get capital Z. So again we are here Z, Z and R. Now as we move forward towards the right hand side, we now get the blank space. Blank space, that means our string is accepted. So how we can write? If we give Q4 state blank space, it will be blank space and right or left, whatever you can write. And this state will be accepted state. This is our Turing machine. But for n greater than 0, there is null string also will be accepted by Turing machine. So for that, we need to draw that also. That means if any null string occurred, that means at Q0 state, if there any null string occurred, it should be accepted. For accepted state, there is Q5 state in our Turing machine. So we can draw like this. Q0 state will be accepted when there is any null string. That means blank space occurs. We will go at Q5 state and you can write right or left. But in exam, if there is given that solve this question for n greater than or equal to 1, then there is no need to write this. For our example, n greater than or equal to 0, we need to draw this, that for Q0 state, blank string will be accepted. This is called as transition diagram for this Turing machine. But as this question asks for 7 marks, we need to write transition table. We need to write transition function for this question. Like this, you need to draw transition table A, B, C corresponding X, Y, Z and blank space, and here used states. In our example, from Q0 to Q5, these are all the states. Now, based on this transition table and transition diagram, we need to write transition functions also. Here, what this means, if we give Q0 state A, we will reach at Q1 state and we will convert this first A into capital X and move towards the right. Here, if we give Q0 state A, we will reach at Q1 state, convert A into X and move towards right hand side. Same for Q1 state. If we give Q1 state A, we will reach at Q1 state itself, keep A as it is and move towards the right hand side. So here what we will be written. So here what we have written, and here also. So now you can see that what I am trying to say. So for each and every state you need to write transition function like this. Now you can also write whatever symbols used. We have taken string AA, BB and CC. So here alphabet used are A, B and C. Now what are the tape alphabet used? That means this is our tape, what we have used. In this tape, we have used some alphabet, corresponding symbols and blank space. So alphabet used are A, B, C. We have used capital X, capital Y, capital Z and blank. So we need to write here tape alphabet tau is equal to this, where X is processed A, Y is processed B, Z is processed C and B is blank. This is how you need to write answer in the exam for the 7 marks.